to another Network Plus study session. Today we're going to talk about the cloud and the data center, and I think it's going to be fun. It's going to be a good lesson about a lot of virtual stuff, um, a lot of data center stuff, how the layout of data centers are, and stuff like that. And I'll go ahead and go over the objectives, and we'll dive field some of the virtual. Sorry, I'm just trying to get comfortable here since we're probably gonna be here for a good, I want to say 30-40 minutes, so I'm just trying to get comfortable. I'm gonna go ahead and start my timer since I consider this study time for me, so I like to start I use an app which I probably mentioned. It's called well, let me see what it's called. I think Forest, actually. And basically what it is, it records the time that you study. So, really good app if you want to be realistic about how long you study. Because sometimes you'll study, but you don't really know how long you study. But anyways, let's get into this. And I'm going to take my jacket off. I am sorry for procrastinating. Like, I'm already sweating for no absolute reason. Alright, so virtual network devices. What are some virtual network devices we might see in the field? The first one is a virtual servers. We'll see virtual routers, virtual firewalls, virtual switches, virtual desktop, voice over IP, cloud computing, and software-defined networking. So we're going to go into virtual servers and just kind of talk about what a virtual server is, which is pretty self-explanatory. It's literally just a server virtualized on a computer, kind of like a VM. So it's literally a VM version of a server using a server. So, of course, I'm starting to yawn. Oh, gosh, let me get a drink of this. Virtual servers allows multiple virtual instances to exist on a single physical server, considerable cost saving for an IT budget. So what does that mean? It basically means you can have multiple instances of a server. You can have 3 servers for the price of 1 server. That's what that means. Allows consolidation for physical servers, which is very cost saving. Multiple NICs increase bandwidth availability. Now we're going to talk about hypervisors. What is a hypervisor? It's specialized software that enables virtualization to occur. Hypervisor is the software that emulates the physical hardware, also called a virtual machine. Monitor. Some examples of hypervisors are VMware, Microsoft Hyper-V, VirtualBox, VMware Workstation. Now let's talk about some virtual storage solutions. There is something called network attached storage, abbreviated as NAS, which it says this storage is delivered as a service over TCP/IP. So over the internet, or over a transfer control protocol. That's what NAS is. I'm thinking that NAS is basically, you could say it's over the cloud, I guess. Because if it's disk storage that is delivered over TCP/IP, that's transfer controlled protocol. That means file storage and stuff. Meaning you could have a NAS, if you guys have ever heard of a NAS box. It's literally like a desktop, except it's just filled with hard drives. And if that's attached to a computer that can access the internet, you could just access your computer over the internet, so to speak, as long as you're running that software, and then get files from it based on what's installed on that NAS drive, and you could drag and drop to your laptop, whatever, as long as the service you're using on that computer is up and running, basically. Storage area network, also abbreviated as SAN. It's a specialized LAN designed for data transfer and storage. So LAN stands for local area network. Transfers data at block level with a special protocol. Fiber channel. or Fibre channel. I don't know. Special purpose hardware providing 1 to 16 gigabytes. I'm gonna go with fiber, even though it's spelled Fibre. Fiber channel over Ethernet, FCOE, removes need for specialized hardware, runs over Ethernet networks. Then it says ISCSI, IP Small Computer System Interface, low cost, built using Ethernet switches, relies on configuration allowing jumbo frames over the network. And then there is, now we're going to talk about InfiniBand, which is virtualized storage. Switched fabric topology for high performance computer. Very high throughput, with very low latency. Direct or switch connection between servers and storage systems. There's also things called virtual firewalls and routers. To fully virtualize your network, you will need a firewall and router. So basically, you will have to have a physical firewall and router in order to fully virtualize your network. Manufacturers offer virtualized versions of their most popular devices. Virtualized routers and firewalls provide the same feature as their physical counterpart. Basically, what they're saying is you could probably buy a virtual firewall or buy a virtual router using their hardware, pretty much. There is also virtual switches. It allows the use of VLANs and trunking to divide up the broadcast domain. Layer 2 control provides VLANs and trunking and provides quality of service and security. Moving on, we're on virtual desktops. Virtual desktops, users' desktop computer will run in a browser, basically. So you can literally virtualize Windows, for example, and you can run that from a browser. Of course, you can't do it without hardware, though. So you have to have something running it in order to access it through the internet, right? You have to connect to that server. Used for web, laptop, tablet, or phone, easier to secure and upgrade for admins. So what is software-defined networking? It provides the administrator with an easy-to-use front end to configure physical and virtual devices throughout the network. All the configurations are automatically done, and it provides administrator and overview of the entire network. Basically, if you do stuff over virtual network, it's easier for administrators to essentially to run it, to admin it. Rather than having to be physically in that location to admin it, they can do it over the internet and do it from home, basically, is what it's saying. Voice over IP, I think a lot of us know what that is. Voice over IP is just digitizing our voice traffic so that it can be treated like other data on a network. So it's basically digitizing your voice over the internet. So in other words, when you play a game with your friend, whenever you're on Discord, basically, whenever I'm on this streaming software, it's digitizing my voice so that you guys can hear it. And that's known as voice over IP, because IP is basically using the internet. And if you ask me, voice over IP sounds 10 times better, depending on where you're located. So the other day, actually, for example, I was talking to a friend on Discord. Sounded way better compared to talking to them over the phone. I tried talking to them over the phone, sounded terrible, but voice over IP had me covered with Discord, because we have Wi-Fi here, but I do have Wi-Fi over calling, but it still didn't sound as good as Discord, so. Virtual private I cannot talk today. Virtual private branch exchange and VoIP. Ability to outsource your telephone system utilizes VoIP to send all data to the provider. Now we're moving on to cloud computing. There is different types of cloud computing. There is private cloud, which is systems and users only have access with other devices inside the same private cloud or system. In other words, no one can use it except for your company. There's a public cloud. Systems and users interact with devices on a public network, such as an internet or other clouds. And then there's hybrid cloud, a combination of private and public, which I'd say a lot of people use. And then there's community cloud, collaborative effort where infrastructure is shared between several organizations from a specific community. If you're basically in collaboration with different companies, you would use that. Then there's different models of clouds. The different models are network as a service, infrastructure as a service, software as a service, and platform as a service. There is also network as a service, which we will... so now we're going to talk about network as a service. We actually mentioned it. I don't know why I said also. What I meant was... now we're going to talk about that network as a service. So network as a service allows outsourcing of a network to a service provider, hosted off-site at the service provider's data center, and customers billed for usage. Charged by hours, processing power, and bandwidth used, like utility service. Yeah. Infrastructure as a service, basically you're using someone's hardware over the internet, pretty much. But I will go ahead and talk about this a little more. So it allows outsourcing of infrastructure of the servers. Hosted off-site, charged by hours, processing power, and bandwidth used. And then there is software as a service. User interacts with a web-based application, is a software as a service, like Google Maps, for example. Details of how it works is hidden from the user, and examples are Google Docs and Office 365. There's also platform as a service, provides a development platform for companies that are developing applications without the need of infrastructure. So basically, they can develop stuff without having the need of computers. Actually, Dion's Training uses PaaS for our courses. And then there's desktop as a service, which they didn't mention above for some reason. But desktop as a service, if I can talk today, provides a desktop environment that is accessible through the internet in the form of a cloud desktop or virtual desktop environment. Now we have some of the different cloud concepts. The first one is elasticity. Attempts to match the resources allocated with the actual amount of resources needed. So it's flexible, basically. Elasticity is focused on meeting the sudden increases and decreases. Now there's scalability, handles the growing workload required to maintain good performance and efficiency. Sorry. Then there's vertical scaling, increasing the power of existing resources, and horizontal scaling, adding additional resources to help handle extra load. Multi-tenacity, allowing the customers to share computing resources in a public or private cloud. Now we're going to talk about virtual machines. Occurs when virtual machine escape. I never heard of this. It's weird. Occurs when an attacker breaks out of one of the isolated VMs and begins to directly interact with the underlying hypervisor. Host virtual servers on the same physical server as other VMs in the same network. It's weird. This is something I also never heard of. Infrastructure as code enables managing and provisioning of infrastructure through code instead of through manual processes. Virtual machines, virtual devices. scripted automation, and orchestration. Orchestration is the process of arranging or coordinating the installation and configuring the multiple systems. Low cost, speeds up deployment, increased security. The snowflake systems. Any system that is different from the standard configuration template used within an organization's IAC architecture. Keeps things consistent and using carefully developed and tested scripts. Connectivity options, VPN, establishes a secure connection between a premise network and a remote office, client device, and provider global network. Private direct connection extends pre-existing on-premise data centers in the provider's network. Now we are going on to data center architecture. A data center is any facility that businesses and other organizations use to organize, process, store, and disassimilate large amounts of data. Types. These are the different types of data centers. There's a 3-tiered hierarchy: software-defined networking, spine and leaf architecture, traffic flows, and on-premise versus host data centers. Benefits of data centers, I guess, is performance, management, scalability, redundancy. And we're going to talk about the software-defined data center. I would say it focuses on, enables the network to be intelligently and centrally controlled. Talks about the application layer, focuses on the communication resource requested information about the network as a whole. The control layer uses the information from applications and decides how to route a data packet. And then it talks about the infrastructure layer, contains the network devices that receive information about where to move data and then performs those movements. And then it goes on to talk about the spine and leaf architecture. Which is an alternative type of network architecture that focuses on the communication within the data center itself. Spine and leaf can give faster speeds, lowering the latency. This architecture can be used in combination with the standard 3-tiered hierarchy. And that is it for this chapter. We'll go ahead and do a summary of what we went over so far. So we kind of talked about a lot of cloud concepts. We talked a lot about cloud concepts, about a lot of virtual hardware we can use instead of using physical hardware so that we can consolidate and save money a lot. So we have virtual servers, virtual routers, virtual switches, etc. So we talked a lot about those virtual devices. We talked about voice over IP. We talked about different cloud-based computing, such as private cloud, public cloud, hybrid cloud. There's another thing we talked about that I wanted to bring up, which was hypervisors. We talked a lot about hypervisors, about how you can essentially digitize a computer, basically use the hardware as software. Okay, so because that's what a hypervisor is. It just turns the hardware into software. Of course, the computer you have has to be able to run that software. So having a very powerful computer to run those things is also important. And I'd say the last thing we talked about was... we talked about a few other things. Let me see. We talked about some of the cloud concepts, such as SaaS, PaaS, DaaS, and how some of the cloud concepts allow elasticity, scalability. It's scalable, it has multi-tenacity. And then last but not least, we talked about data centers and how they're how in the data centers, how their architecture is set up. That's gonna be it for this section, and I will be back on later after I take a short break. And that is gonna be it for now, so